Good morning to all. Today we are going to see the topic called algorithmic problem solving. First step, we need to know what is algorithm. Algorithm is a step-by-step instruction used to produce a desired result as it gets executed in the specific order. So we all know about the algorithm. It is the main step in solving a problem. After algorithm only, we will proceed with the next part of the code. Now, what is algorithmic problem solving is the process of designing and implementing a solution to the problem, that is designing of an algorithm. This process will be carried out in few steps, and the goal of this algorithmic problem solving is to find an effective solution to the problem. As we see, each and every problem will have so many solutions, and we need to find an optimal solution out of all, with the main two things called time and space complexity. So to achieve that, what are the steps in algorithmic problem solving, we can see in the next slide. So the steps for problem solving is, the first step is we need to understand what is the problem statement is and what are the what are the requirements of that problem. That is the thing which we need to know in initially. So that is the first main step. We need to understand the problem. The next is we should decide on computational means. That is, we need to decide what are the inputs recommended for that problem and what are the outputs, what are the outcomes, what are the possible outcomes required for it, and we need to check whether it is computationally solvable or not, because certain problems cannot derive at a single solution, and we cannot assure that that solution is approximate. As we can see that finding square root of a number, every time when we are taking a square root, it will have too many solutions. Out of that, we should see which is computationally exact solution. So the next step is to design an algorithm. For that, we are having several representations like flowchart, algorithm as like a simple English language statement, or else pseudocode. We can have so many representations to represent the algorithm. The next is we need to prove the correctness of that algorithm. Once we have designed the algorithm, we should show the correctness of it with the help of two main parameters called time and space complexity, as well as the desired output. The next thing is we need to analyze the algorithm, whether it is efficient or not, based on the time and space occupied by it. The next thing is, once we have analyzed that it is good and effective solution, we can move for the further step called designing of that algorithm. That is, we can move for the coding part of it. So these are the steps involved in algorithmic problem solving. So the first main step is to understand the problem. Here, to understand the problem, we need to find what is the inputs recommended for that problem, and we need to specify any conditions or controlling parameters available for that algorithm. So based on that, we can handle those inputs, and we can aim at proceeding with the desired outcome. So this is the first main thing, that is understanding the problem. The next is decision on computation. So here, once we are finding whether the solution is computationally exact or approximate, we should find, when we are understanding the problem, we can have a desired outcome. That desired outcome can be exact solution or as approximate solution. Here there are two main solutions can be achievable. We should decide which solution we will obtain in future. The next is, I have given certain examples for exact solution as well as approximate solution. Finding square root of a number and solutions of nonlinear equations will proceed with the outcomes, but it may or may not be exact solution, because every time when we are for taking square root of a number, we will have several solutions. We can have different floating point values, so that we cannot have exact solution for that. The next thing is deciding a data structure for the algorithm. When we are proceeding with the algorithm, we should fix which kind of data type or data structure needed to store the inputs and for proceeding the execution step. The next step is algorithmic design. So for once when the algorithm is fixed, we can represent it in the form of simple English statement like for frequent step. That is, we can have several control structures like sequence structure, selection structure, looping structure. So based on that, we can decide which structure to get followed in that algorithm. We can design it with the help of normal English statement, or else we can move for graphical representation like flowchart. We can design that algorithm in graphical representation, or else we can move for pseudocode. So pseudocode is the false code representation of an algorithm. So we can have n number of representations. We can decide which one will better suited to that algorithm, and we can proceed with that. The next thing is to prove correctness. So in this step, when we are having, we should see for all the inputs, either we are getting the desired outcome or not. So we should decide which technique to prove the correctness of that algorithm. Either we can go by mathematical rules, or we need to proceed with the specific iteration. That is, we need to check all the test cases to get solved, as to check whether the desired outcome is obtained or not. So in that way, we can prove the correctness of the algorithm with the base case as well as with the general conditions. So next is to analyze the algorithm. Once the algorithm helps us to achieve the desired thing, that is desired outcome, we should check for its efficiency. Efficiency can be verified by two main parameters called time and space complexity. The minimum time required to run the algorithm is called time complexity, and the amount of memory required for that algorithm to get processed as a program is called space complexity. So the algorithm should have minimum time complexity as well as minimal space complexity. It should not use extra memory. And then the simplicity, it can also prove the algorithm's efficiency. That is, it should be understandable by all the person who are not aware of any programming language. So the algorithm must be simple, and it should be unambiguous. It should be clearly verified by each and every person, and it should contain fewer bugs. Even though if it is containing any bug, it should be easy. It should get easily tracked by our algorithm. That is, the algorithm should be as simple as such that to easily find out the bugs. The next is, once when we are satisfied with the algorithm, we should proceed with the program implementation. We can have any programming language to transfer the algorithm to a perfect program. So while we are designing the program, we should maintain the syntax of the programming language, and we should check that whether all the steps specified in the algorithm gets transferred as a program. And every time when we are running the program, we should get the desired outcome, so that we should mainly concentrate on the syntax and the outcome of the program. The next part of the coding is to check for bugs. That is, debugging is the main role, testing and debugging. We should verify that whether all the requirements which is mentioned in the step 1, that is, while understanding the problem, we have mentioned the requirements which needs to get satisfied while designing the algorithm. All things should be verified at the last phase of this algorithmic problem solving. So these are the main steps involved in algorithmic problem solving. So based on designing these algorithms, we can proceed with the coding and implementation part. So I have ended the part. Thank you.